This is the video lesson for geometry, section 7.1, ratios and proportions. In this lesson, we're going to write ratios and solve proportions. Starting with this little warm-up activity, here is a table with the years, the wins and losses of a baseball team. In which year did the team have the best record? Explain. So press pause and see if you can figure out which year had the best record. And then check back and see if you got what I got. Okay, so hopefully here you noticed that they actually didn't all play the same amount of games every year. So in order to get this on apples and apples to compare them, right, you need to figure out what does the word record mean. The best record means the most wins out of total games. So you need to figure out what the total games were and then take the ratio between wins and total games. And so here you can see I did the wins divided by total, and these 2 years had the same exact winning percentage, which was higher than these 2 years. So both 1890 and 19 have the best record. Okay, so what we're doing here is we're comparing two quantities, right? A ratio is a comparison of two quantities, and they can be written either as a fraction, a to b, with these colon in between them, or actually just the words a to b. So both of these can be read how a compares to b, or a to b. That is a ratio. And here, right, we're looking at the ratio of wins to total games. That's what a record is. So we're talking about ratios. So this first problem, it says a bonsai bald cypress tree is a small version of a full-size tree and stands 15 inches tall. A bald cypress tree called a senator stands 118 feet tall. What is the ratio of the height of the bonsai to the height of the tree? Okay, for these, so ratio is going to compare two quantities. It's also going to be the lowest common factors in the ratio, and then so you're basically going to cancel out any common factors to get the, like if it's 4 to 8, you're going to reduce that to be 1/2, right? That's also what a ratio is. So let's see, and you also want to use integers. So here we have what's the ratio of the height of the bonsai? So this is the bonsai to the height of the tree. Okay, so we're going to set up like a ratio, like a fraction. So the bonsai is 15 inches tall, and the tree is 118 feet tall. All right, so the first thing we want to do is get them in the same units, right? We can't compare 15 to 118. They're not the same units. So if we turned inches into feet, we would have a decimal, and in ratio, we want to have an integer. So we're going to turn our 15 inches into feet. And we know that we have 12 inches in 1 foot. And anything like that that you need, I will be giving you. You don't need to memorize those. So remember with changing your units, you divide by inches and then you multiply by feet so that the inches cancel. And let's make this equivalent to 1, which is 1 foot, 12 inches. Okay, so I actually made a mistake here, right? I just told you guys that I wasn't going to do this. 15 divided by 12 here is 1.25, and we don't want decimals. So I actually want to turn this into inches, right? So let's do 118 feet, divide by 1 foot, and multiply by 12 inches. And that way, 118 times 12 is 1416 inches. Okay, and so then the ratio would be 15 over 1416. Then we just want to make sure they don't have any, you basically want to get the reduced fraction here. So this is a 3 and a 5. So this definitely doesn't have a 5 in it. It does have a 3 in it though, because if you add up the digits, 6 plus 4 is 10, 11, 12. 12 is divisible by 3, so that means 1416 is divisible by 3. So if we divide these both by 3, right, this becomes 5, right? This is 5 times 3, and this is 472 times 3. These 3's cancel. So then this is 5 over 472, and then 5 does not go into this because it doesn't end in a 0 or a 5. So this is the most reduced fraction, and the ratio is 5 to 472, and this is inches. But that's the ratio, okay? You can also do this in decimals. You could actually put the 15 over 1416 as a fraction, and then in the corner of when you do decimals, there's like a little button that looks like this. If you click on that button, it'll reduce the fraction all the way, and you should get something like this. So Desmo should help with that too. Okay, so try this one on your own. Press pause and then check back for the solution. Okay, so for this one, we are comparing the width to the height. And they give us the width in inches and height in feet. So we turned our feet into inches by multiplying by 12. And then we had 18 and 24, which they're both even. So I pulled out a 2 and canceled, so 9 to 12. And then I just factor, I knew 9 is a 3 and a 3, and 12 is a 3 and a 4. So the 3's cancel. And so this ends up being 3 to 4. So the ratio of the width to the height is 3 to 4. Okay, moving on. Problem 2 says, members of the school band are buying pots of tulips and pots of daffodils to sell at their fundraiser. They plan on buying 120 pots. And the ratio, which is the number of tulips to the number of daffodils, will be 2 to 3. How many pots of each type of flower should they buy? Okay, so on the last one you saw, right, we were reducing fractions. And these ones were actually going to be building up fractions, right? So if the final ratio is 2 over 3, that means the original ratio is something like 2x over 3x, where x is in common and it got canceled to go down to the 2 to 3, right? So we want to figure out what that x is so we can figure out what these numbers are. So if the actual ratio is 2x over 3, or original is 2x to 3x, we need one more thing of information so we can relate them to solve for the x. And here we have, they plan on buying 120 pots. So if this is the original of tulips, 2x, and this is the original daffodils, we can add them together and we should get 120. So that's the equation we're going to use to solve for this x. So this is 5x equals 120. You divide both sides by 5. 120 divided by 5, it should be 40, right? No, 24. So x equals 24. And so that means, right, this is 2 times 24 over 3 times 24, where the 24s had canceled, excuse me, to get to the 2 over 3. So see, we're just doing this problem backwards than we just did the last one. So then we just need to do 24 times 2, and this was 48. And then 3 times 24 is 72. So this was the original number. And so how many pots of each type of flower should they buy? 48 tulips and 72 daffodils or pots. Okay, so see how that works? You got to use that x. Okay, so try this one. This is a little bit simpler, but you need to know what supplementary means. Hopefully remember that they two add up to 180. And they're in the ratio 1 to 4. What are the measures of the angles? So press pause, try this on your own, and then check back for the solutions. Okay, so for this one here, right, the x ends up being 36, right? Because when you put your x there and you add them up, you get 180. We get x equals 36. So then you multiply them out, it's 36 and 144. When you add them together, you do get 180. So the two angles are 36 and 144. This also works with 3 or more numbers. This is called an extended ratio, like A to B to C. So let's use this as an example. The ratio of fruit, apples to oranges to bananas, if it's 2 to 3 to 5, right, then each one just goes up to scale. These just have to go up by the same number, right? This is times 2, times 2, times 2, right? Or this is times 3. So it's just the same exact thing. It's not as easy to see with a fraction, right? It would be like 2x to 3x to 5x. In this case, like x is 2, in this case, x is 3, in this case, x is 4. So it works the same way with an extended ratio. So let's see how that works. And this word problem said the lengths of the sides of a triangle are in the extended ratio 3 to 5 to 6. Right, so if that's true, then the actual are 3x, 5x, and 6x. And they're talking about the lengths of the sides. So let's just call that 3x, 5x, and 6x so you can see it. And then the perimeter of the triangle is 98. So when you add them all together, they should equal 98. So 6 plus 5 is 11, plus 3 is 14. 14x equals 98. Divide both sides by 14. 98 divided by 14 is 7. So this is 3 times 7 is 21, 5 times 7 is 35, and 6 times 7 is 42. So this is the actual lengths, right? And then the question says, what's the length of the longest side? Well, that would be 42 inches. So try this one on your own and then check back for the solution. Okay, so here, if you put in your x and you add them all together, you get 20x equals 60, so x is 3. So then each one is, you just multiply 3 times each one. So 12, 21, and 27. And if you just double check, it does equal 60, so you did something right. And just add your units. So 12 centimeters, 21 centimeters, and 27 centimeters. Okay, so moving on to proportions. You guys are probably used to seeing this in algebra and pre-algebra proportions where it's like A over B equals C over D. And here's just a little bit more vocabulary with this. So here when the ratios are, two ratios are equal, you can write them like this, right? The ratios, the two outside ones, the first of one and the last of the other are called the extremes. And then the two in the middle are called the means. And when you write it as fractions, right, the extremes, like when you do cross multiply, the extremes equal, the product of the extremes equals the product of the means. So it's called a cross multiplying. And so this is really just cross multiplying to help you solve proportions. So let's see that in action. What's the solution of each proportion? Oh, whoops, I left a little arrow there. That's okay. Here, we'll just, right here are the means, here are the extremes. Multiply them together, 24 equals 5x, and then divide both sides by 5 to get your excellent. You can leave this 24 divided by 5 is, and you can just leave that as a decimal, 4.8. Okay, and then a little trickier with algebra. Here, this is 3 times y plus 4, so you have to put it in parentheses, and this is 9y. And then you distribute 3y plus 12 equals 9y. And then you have to get your y's on the same side, so subtract your 3y. This is just algebra. So y is 2. Okay? So try these 2 on your own, and then after you pressing pause, and then check back for your solution. Okay, and so for these two, I solved this one a little differently. If you notice this, right, this 2, if you just match the bottoms or match the tops, then you can then match the other bottoms or tops. So this one I noticed that if I just multiply this 2 by a 7, I would get a 14. So I also did that on the top. So 63 over 14 equals A over 14. So then A is just 63. That's just another way of solving them. You can cross multiply and get the same thing. I just wanted to show you that way. It doesn't work for all of them, but especially not these ones. Here you just distribute and then get your m's on the same side, and then m should be 1/4. Okay? Okay, and then the last concept here is properties of proportions. So in this first property, so here's our proportion. You can actually flip the ratios and it's still equivalent, right? A over B equals C over D. You just flip them both. The reciprocals are both going to be congruent, or sorry, not congruent, equal. Here you can actually flip the, switch the means. That still works because, right, you're still multiplying them either way. And then for this one, right, if you add the same thing, if you add the bottom to the top on both of them, then they're still equivalent. Yeah, if you add the denominator to the numerator, that still works. Okay, so let's do those in action and then we'll be done. So here in this example, we have triangles. In this example, x divided by 6 equals y divided by 7. Okay, so to get here, let's see. Let's start with our x over 6 equals y over 7. Well, why don't we can remember from that second property, we can switch the means. So this becomes x over y equals 6 over 7, which is what this is asking, over 6 over 7. So this is the property of proportions number 2, when you switch the means. Okay, and then for, why don't you then try these 2 on your own. So press pause and then check back for the solution. Okay, and this one you can see you just flip this one, you can just do the reciprocals. So 6 over x is equal to 7 over y, and that's the reciprocal property number 1. And then this one you can see the denominator was 7, here we added that to the top, so you're going to add the denominator of 6 to the top here. So x plus 6 over 6 there, and that's your property number 3. All right, and that is it. Enjoy.